Okay, here's a video on graphing inequalities on the coordinate plane, or the Cartesian grid. So we've already plotted points on a grid with linear equations. We graphed linear equations basically the same way with a few differences. So before we do that, let's make sure we know how to put them on a line graph. We'll review. Let's say I had, let's write this out, say I had something like this. Make that 10. How would you write that? If you saw that, how would you write that inequality? Okay, well, we can use any variable. We'll just say x for now. We're saying x is less. The arrow's pointing this way. It's less than 10. Simple as that. Let's do another one. And what if we saw something like this? How would you graph that? How would you write that inequality? Okay, again, any variable you want. Usually we just use x. So we're saying x now is greater than 3. And of course you can put it, right, you can make it that way if you want to. Doesn't matter. Let's do one more. What if you saw something like this? What if you saw something like this? And we've seen something like this when we did floating bar graphs. Okay, so again, we use any letter. Well, let's use x for a variable. Now we're saying x is greater than -1, because it's not filled in, but it's less than or equal to 2. Okay, those are line graphs. But now let's do inequality equations, and we'll put them on a Cartesian grid, or a coordinate plane. So here we have y is greater than x plus 1, and we've done this when we said stuff like y equals. So we're going to make a domain and range box, or an x and y box, x, y box, right? And we know that the x is on top, y is on the bottom. We know the x is the independent variable and the y is the dependent variable. So we can just put in any numbers we want. So we can just put -2, -1, 0, 1, 2. We'll just do it like that. And we'll fill it in the same way we've done linear equations. So see if you can answer these questions for y. So pause the tape and do that. Okay, so if x is -2, so we have -2. -2 plus 1 is -1. So y has to be greater than -1. Same as we did with the linear equations. Now if x is -1, we have 0 for y. Y has to be greater than 0. Then we have 1, 2, and we see the pattern. Okay, so now we have our domain and range box. We have our numbers, our pairs. These are our pairs here. And now we can just plot them on a grid. Okay, so we'll put our grid up here. We'll put our pairs over there. Okay, so now we have, now this is the origin, this is 0, 0. When x, this is -1, -2, excuse me, this is -1, that's -2, that's a +1, +2, 3, 4, 5, and so forth. So when x is -2, I'm bringing that box over here. When x was -2, y has to be -1. So when x is -2, y is -1. And that's -1, -2. There's our first dot. And then we see another one. When x is -1, y should be 0. When x is -1, y is 0. So there's our next dot. When x is 0, y should be 1. When x is 0, y is 1. So far we're going up. We're making a linear inequality here. When x is 1, y is 2. And when x is 2, y is 3. And we can see, we can just keep going actually. When x is 3, y is 4, and so forth. Now, we're not going to draw a line yet. We're going to just leave it at that. Now, when we do inequalities, you're either going to have a dotted line or a solid line. If you see a dotted line, that means we're using these types of inequalities. I'll bring this down for a minute. You're either seeing greater than or less than inequalities. So in our equation, in our inequality equation, we saw this type of an inequality. We're saying y is greater. We're not saying y is greater or equal. Since we're only saying greater or less than, we're using a dotted line. So we're using a dotted line. So we're not going to draw a line. Now, if we see greater than or equal to, we see this type. Sometimes you see it like this. If you see those type of inequalities, it's a solid line. Solid line. And we'll do one with a solid line. So again, we're seeing this type of inequality. Let me write the equation again. We're saying y is greater than x plus 1. Since it's that, it's a dotted line. Now, the next step. This dotted line is also called the boundary line. So we'll write it down, the boundary. That's the boundary line. Whether it's solid or whether it's dotted, it's called the boundary line. Now we want to know, since this is an inequality, where is it heading? In other words, we want to know what side of the boundary will it solve this equation? Will every point solve it? So here's the boundary line, and we know we can make some more points down there. We'll make another one up here. So this inequality will be solved with every point either on top or every point on the bottom of the boundary line. So one of these areas will be shaded in, and they're called half planes. So this is one half plane, this is the other half plane, because this is the boundary. It's the edge of two countries, the edge of two borders. Okay, so in other words, here we have y is greater than x plus 1. So if I pick any point, any pair here, or any point here, only one of them will work. One of them will be true, one of them will be false. So how do we do that? We do test points. Okay, so we'll pick a test point. And the first test point we'll pick is somewhere in this side. Let's just pick somewhere over here. So what if I pick this test point A, that x? Let's see if it works. We're saying now if that's the test point, we'll make it test point A. And we're saying test point A, we'll look at the pairs for test point A, is 0, and we're going 1, 2, 3, 0, 3. Let's see if it works. Where x is 0 and y is 3. Remember, x comes first. So we'll come up here. If x is 0 and y is 3, we're saying 3 is greater than 0 plus 1. Is that true? Yes. So test point A works. Put a check mark there. Let's see if it works on this side. Let's do something right here. Let's say right there. Let's make that test point B. So in test point B, we're saying it's at 3, 0. That's the pair. That's the coordinate pair for that point. Let's see if it works. So we're saying now that y has to be 0, and 0 has to be greater than 3, because x is 3 plus 1. Is 0 greater than 3 plus 1? No, this is false. We know that this does not work. So we know now that the inequalities will work on this side of the boundary line. Just put some arrows here. So let's clean that up. Do this one more time. So we're saying now that y is greater than x plus 1. And we already put in our pairs. Right? And we kept it a dotted line because we're saying this is the inequality. We're not saying that y is equal to, we're saying it's greater than, so that's why it's dotted. And we did our test points to see which side it goes on, and we said that this works right here, and we said this does not work. Since this does not work, we're not shading in this side of the plane. Everything on this side, put our arrows, works. So this would be shaded in. And that's how you would solve it. So we can check one more time. Let's pick any point above the boundary line here. Let's pick that point. 1, 2, 3, 4. So that's saying, that point here is saying negative 4, and it's 1, 2, 3, 4. Negative 4, 4. Let's see if negative 4, 4 works. So we're saying now that 4 is y, and it has to be greater than negative 4 plus 1. There we go. And negative 4 plus 1 is less than 4. So it works. Okay. Let's see if you can do one by yourself. Try this. Pause the tape. See what you can do. So first, make a domain and range box. Make an x and y box. Put any numbers you want. Usually you should start with some small numbers to fit on your grid. Plot it. And then C puts in some test points and see which side of the plane of the boundary line does it belong. Now first ask yourself, is this going to be a solid line or a dotted line? Look at the inequality. We're saying x plus y is greater or equal to negative 1. So, or equal, remember, this is not going to be a dotted line. This is going to be a solid line, either positive or negative. Remember, if it's going up, it's positive. If it's going down, it's negative. So try that. Make sure you have graph paper. Pause the tape and try that. Now this is not in slope-intercept form. It's in standard form. And if you want to make it easier for yourself, you can get the y all alone by minusing the x on both sides. So now it would be y is greater or equal to negative x minus 1. You can do that if you wish. Whatever's easier for you. So let's do a few of them here. Let's say x was negative 2. X is negative 2, and then we'll just do stuff like this. Bring x's like that. So if x is negative 2, and you can do it this way or use that. So negative 2, you're saying now a negative 2, which is 2. Negative and negative is positive. What's 2 minus 1? It'd be 1. And if x was negative 1, negative 1 is 1. 1 minus 1 is 0. If x was 0, 0 minus 1 is negative 1. If x is 1, not negative 1, if x is 1, it's negative 1 minus 1, which is negative 2, and we have that. So what do we do from here? We graph it. Okay, so we'll just bring this here. So again, if x is negative 2, we're saying that y is 1. Put that over there. We're saying if x is negative 1, y is 0. If x is 0, we're saying y is negative 1. If x is 1, we're saying it's negative 2. If x is 2, it's negative 3. And it's going up this way too. Now, we said it's not dotted. Let's write the equation up here. Bring the equation over here. Right? We're saying it's a solid line. And we have a negative solid line. So we're going to make this whole line solid. The reason it's solid is because now we're saying that everything on the line also is in the inequality. So now, it's either we're going to solve this inequality. Every point on this side or every point on this side is going to solve it. So we need some test points. So we can put a test point here or anywhere you want, and we'll put a test point here and see which one works. We can even put a test point here. Wherever you put the test points, you can see which one works. So let's try this one. This would be 0, 3, 0, 2, that is. This is 0, 2. And we have this one here. This is 3, 0. 3 is negative 1, that is. 1, 2, 3, negative 1. And this one is 1, 2, 3. This one is negative 3, negative 2. Okay, so up here, now again the equation was x plus y is greater or equal to negative 1. So if we plug in this one, we're saying 0, because x is 0. 0 plus 2 is 2, right? And 2 is greater or equal to negative 1. So this works. So far we know that the line should be going this way. But let's test this point. So here we're saying 3 plus negative 1 is 2, and 2 is greater or equal to negative 1, so this works. Let's see if this works. Negative 3 plus a negative 2 is a negative 5, and that's not greater or equal to negative 1, so this is false. So we know now that to solve this inequality, every point going this way, we just put lines, works. So that is graphing inequalities. Great job.